Hello and welcome. Welcome to the MAT 0028 online class. I am Professor James Wilson and I am hosting today's session. At this time, it is 5:30 Sunday. It is November 13, 2016. I'm currently here, and right now there is no one online. However, because we're scheduled to start at 5:30, I want to make sure that we do start on time so that those catching this on the rebroadcast can have a full hour of presentation and problems that we've worked out. First thing I want to do is mention that for those of you who are just kind of wanting a snapshot of everything, I do want to mention that our next test will be the 21st. So according to my calendar, that looks like that is going to be not this Monday, but the Monday after next. So please pay attention to that and make sure that not just test number 2, but that all of the homework and tests are turned in by that time. Now, I want to make sure that I am recording the right thing. Okay, looks like it. All right, good. Okay, so what we will do today, since there is no one on the time, I'm going to go over some of the problems from the practice test. I believe, if I am not mistaken, that I have a practice test online. If you look on the left-hand side, and you're going to look for document sharing. There it is. If you look in document sharing, okay, so it looks like it is not there. What you will see is chapter 11 and chapter 12. And those people who come here, I will show them exactly where it is. But for now, the test, remember the test number 2 is going to cover chapter 11 and 12. So that's why the test that you see here is a chapter 11 practice test. And that is what we're going to be going over for this session. All right, I'm going to turn on my annotation here and I'm going to go ahead and get started. Let's see here. Using red 24. Okay. Let me also, while I'm at it, let me blow this up a little bit more so that you can see it a little bit better. Let's even make it even bigger. There we go. This should be good. Okay, now I'm going to have to do a lot of erasing because what I'm doing right now is annotating. So what that means is that whatever I write is not going to stay on the page as I move this page around. So if you have to catch the video, some of you who are catching at a later time will have to come back and see the earlier problems. Okay. They want me to find the GCF of this. And let's see how my thing works. It is very difficult to write on this. It's a non-standard writing pad. So my handwriting is going to be everywhere right now, but it's all right. Let's try number 2. You have 36 and 15. One of the ways that I like to find the GCF is, well, one way is to remember the F of GCF means factor. So this means G is greatest, C is common, F is factor. So you could list all the factors of 36, meaning you list all the numbers that go into 36. That would be 1, but most people don't start from 1. They start from 2. 3 goes into 36. 6 times 6 goes into 36. 12 goes into 36. 18 goes into 36. And of course, 36 goes into 36. So these are what we call factors. Okay, so these are factors. Now, when we look at 15, we only have 3 and 5, right? Now, you can see that we have common factors 1 and 3, but the G of greatest common factor, what is the greatest? So you can see here that it's 3. All right, let's try it with, let's try factoring out the GCF. Let's try number 5. Okay, so here we have 56, x7, y7. We also have 64, x5, y5. 24, x2, y2. All right. In this one, I'm going to do it a little bit differently, and this is going to be a longer problem. I'm already anticipating that I won't have enough room. And you know what? If I go out of this, I can scoot that over. All right, so I wonder if they will let me, select? Yes, they will. Perfect. All right. All right, so just trying to clear some stuff here. Erase. All right, go back to the drawing board. You know what? Let me, there we go. All right, number 5. All right. Now, in this particular problem, what we're going to try to do is write the prime factorization of each of these. And I'm doing this a very slow, long method. Because if I do it this way, sorry about that. I have to get used to writing with this. So 56, for instance, we know is 8 times 7. And since 7 is a prime number, I'm going to circle that. 8 is 4 times 2. 2 can't be broken down anymore. That's a prime number. I'm going to circle that. 2 times 2. So 56 is 2 times 2 times 2 times 7, right? So I'm going to write that down. Let me see here. Two, 7, and then we have 7 x's, which I'm not even going to write. I'm just going to stop. I'm going to stop there. We can, and some of you will see why later, but all right, 64. Well, I already know 64 is 8 times 8, and we already found out that 3 2s is equal to 8, right? Because that's 2 times 2 times 2. So we already found that out. So what I'm going to do is I'm going to write 8 times 8. That means I need 3 for the first 8 and 3 for the second 8. That makes 64. have 5 x's. Maybe I can fit all these. And 5 y's. Can't fit them. And it's going to be too much trouble to try to move these over. But they'll do for now. 24 is 8 times 3. That's 3 eighths. And a 3. 8 times 3. 2 x's. And 2 y's. All right, so to find the GCF, we are going to do, remember, G is greatest common factor. So how many 2's? What's the greatest amount of 2's that is common to all 3? All right, listen to that question again. What is the greatest amount of 2's that is common to all 3? Well, I would say 3. See, it's common to all 3. Remember, this is greatest common factor. So this is how you do it this way. So I'm going to write it 3. I'm going to write 2 3 times because it was common. Greatest common. It was the greatest number of 2's that was common to all of the numbers involved. I'm not going to write a 7 because 7 is not common to all of them. I'm not going to write that. I'm not going to write the 3 because the 3 is not common. So what's the greatest amount of x's that are common to all of these? Well, if you got it from what I did on this last one, you would say, well, there's an x, so that's 1x. 2, I can't get any more out of all of them, not that's common to all. So the greatest amount of x's that is common to all would be 3. 2. Likewise, well, what's the greatest amount of y's that is common to all? 1, 2, 1, 2, 1, 2. So 2 y's. Which, by the way, if anyone had a question on why I didn't write the rest of the y's, it was because I knew I wasn't going to need them and I had run out of space anyway. So what number is this? Well, we already know that 3 2's is 8. X squared, y squared. Now listen, this is the GCF. It is not the answer to the question. They told me to factor out the GCF. They didn't say find the GCF. They said factor it out. All right, so I'm going to erase this. Those of you who need help with this, we can come back to this again. I'm going to clear this out, okay? So, and let me get off this annotation. All right, so since I'm factoring it out, and we said that, okay, so well, let me just put it this way. It's much better when people are here with me because then I know the kind of questions. But I'm going to, for me having taught this lesson, I'm going to anticipate the questions here. Factor it out means that I put 8x squared, y squared, and you're literally taking this out because it's a GCF, so it can be taken out of all of these terms, meaning each of these terms can be divided by this number. Just look at the numbers. Each of them, 8 goes into all of them, right? I could take 2 x's from all of these. I could take 2 y's from all of these. So that is a GCF. But what is left over after I take it? Well, what happens when I say take something from something, the operation I'm referring to is division. So when I take 8 from 56, it's dividing, All right, it's a division operation. So 56 divided by 8. Okay, so that would be, let's do 7. If I take 2 x's, I'm still on this first one here, from 7 x's, then we should know how many x's are remaining if I've just taken 2. Remember, I factored this out. So that should be 5, right? And then same with the y. The idea being that if I were to FOIL this back out again, or not even FOIL, if I were to distribute this back out again, 8 times 7, I would get this term. 8 times 7, 56, x2 and x5, x7, y2, x5, y5, y7. Okay. So basically, we should be able to get that. So perfect. Now, let's do the next one. All right. Plus 64 divided by 8 is an 8. Taking 2, so this would be y3, x3, y3, right? And then 24 divided by 8, that's 3. And we're already taking 2, so there's nothing else to take. So this plus sign is getting on my nerves. Plus 3. Now, answer to number 5. This is what I'm calling as my answer here to number 5. x8, x2, y2, and then times, and make sure you have those parentheses there. That's important. 7x5, y5, 8, x3, y3 plus 3 for number 5. Let's check it. Here it is. Checking that answer. Looks good. All right. What I'm going to do, if no one comes on by 6, that would have been half an hour. I'm probably going to go ahead and shut this down, assuming that people did not need the help, because I really want to make sure that I am here for you. But, you know, I'd want you to be here. All right, let's try to get this out and do something else. All right, good. All right, let's go on. What's the other kind of problem you're going to have on the test? A grouping problem and a factoring. Let's do a grouping. And then, I don't know, by the time I do grouping, it may be 6. All right, annotate. Let's do number 9. Let's do number 8 because I don't want to, just in case someone is not familiar with grouping, 8 is easier, and we can do 9 later if anybody comes on or doesn't understand this one. Okay, so we have 3xy plus 12x plus 7y plus 28. Our first step is to add parentheses. You want to add it over the first and second term and then the third and fourth term. So I'm going to add a parentheses before the 3. Oops. And after the 12x. Why is that happening? What in the world? Sorry about that. We are experiencing some serious technical difficulties here. Um, but it kind of is good because it forces me to have to go really slow. Then we're going to add before the 7. Oops. And after the 28. The next step is to factor each of these separately. So we're going to look at this, and we're going to factor out a GCF from both of these. So I'm going to factor out a GCF from this one, and I'm going to factor out a GCF from that one. If you look at these, looks like 3 will go into both of these, and looks like X, I can take an X from both. So it looks like 3X would be my greatest common factor. And I'm going to look at these independently of each other. So since I can take the 3X out, 3X is taken out. Well, when I take a 3X from here, it leaves me with a Y. When I take a 3X from here, it leaves me with 4. I'm going to check that because 3X times Y is 3XY, and 3X times 4 is 12X. So I know that that is correct. I'm going to do the same thing here. Looks like my GCF is 7, because 7 will go into both of these. 7 times what is 7Y? 7Y. 7 times what is 28? So 4. Okay, so now a last step with factoring by grouping is to see what term is common in both this one and this one. So if I look at this term and I look at this term, it looks like Y plus 4 is in both terms. So what I'm going to do then is write Y plus 4. I'm going to take out that Y plus 4. And when I remove, in the same way that I took out a 7 from both of these, I'm taking out a Y plus 4 from both this one and this one. So when I take out a Y plus 4, or when I divide it by Y plus 4, so if I have this and I'm dividing by Y plus 4, remember, take out is a division operation. Well, what's it left with? It's left with 3X. And when I take out a Y plus 4 from this second one, I'm left with a 7. Therefore, that is your answer. These are actually lots. They don't look as simple. I know when you're doing them, and okay, and I don't even need to check the answer. I already know that this is the right answer, but for those of you who are unbelievers, look at, here's 8. And here we have 3X plus Y plus 4. Obviously, remember, commutative property allows us to have this in any order. So the Y plus 4 does not have to be first in order for it to be first. It can be second, or it doesn't matter the order. Okay. Let's do one more. And then what I'll do is I'm going to stop the record, but I'm going to stay on because I promise to stay on. So I'm going to do one more. Then I'm going to stop recording, but stay on. And if somebody else comes on, I'll start it back up again, but I'll stop the recording so the recording isn't just going without anybody on. Let's clear this. All right. We're still doing test prep here. Let's go to, I'm trying to do one per section here. So I guess Right. At this time, I should be at this one. Between all of these, okay, so prime means that it cannot be factored. So when I'm looking at 12, I would look at all of them. When I look at 12, it's stop pausing. It says it's paused. We do resume. Okay, there we go. All right. When I look at 12, an easy way a lot of people like to do this is, let me see something here. You know, to put the negative, to put that middle term over here, that -1, because that's the constant in front of the x, and the -12. See what numbers multiply to 12, but add to a -1. So it would be -4 and +3, right? So then that's your answer. X -4, x + 3. It's the same thing here for the 14. The 9 is on this side, 14 on this side. What multiplies to 14? 7 times 2. Those numbers already add to 9. So that's my answer. X + 7, x + 2. With this last one, this looks like a difference of squares. That's going to be different. So in the difference of squares, we remember the rule is it's going to look like this, where one is a plus, one is a minus, and you take the square of both. So what's the square root of z2? Well, just z. What's the square root of 121? 11. So this is your answer. Now, these are pretty simple. I know that they don't look like they should be our answers, right? Where am I? Yeah, here it is, 14. See, z + 11, z - 11. The 2 and the 7, the 3 and the 4. All right, so I did all of those. And all right, it's 5:59. I have not had anyone come on yet, but I do want to say that for this, for what we've done so far, I really hope that you have gained something from what I've done so far. Even with one person on, I would have just kept going, because, like I said, I'm here for you. But if no one needs it, then I'm going to just remain on. But I'm going to stop the recording at this time, and then we'll let you know when our last session is. I want to thank you again for tuning in. Hopefully you will find this screencast has been helpful for you. Please let me know if you have seen it and it's helped you out. And maybe, who knows, we may be able to do another one. They don't always have to be scheduled. We can just kind of throw one in there, so long as my schedule, it works with my schedule and your schedule. All right. Thank you again. And until next time, we'll see you later.